Hey gang, just following up on what I'd mentioned yesterday, there was 4 more samples that I wanted to give you time to work through, make sure you've got a handle on these absolute value equations and inequalities. But we ran a little tight on time, so I'm going to walk through 4 of these and make sure that everybody's got a good example of each type that we can come across. So let's start with number 1 up in the top left there. So we've got an absolute value statement there. Of course, the first thing we need to do is get that absolute value sign by itself on one side of the equation. So subtract 3 from both sides, no problem there. Now that absolute value could be positive or negative, so we're going to write that as 2 separate statements. We can say 3/4 x minus 2 is equal to 6, or negative 3/4 x minus 2 is equal to 6. Those are our 2 cases that we need to consider. Now solving each one of those is really just a matter of solving each linear equation, and I'm confident that you could all do that. And if you do that, you should find that your 2 solutions are 10 2/3, that's the solution to the left scenario, and negative 5 1/3 is the solution to the right scenario. So that's an equation, so we're not going to have a whole region of solutions. We're just going to have 2 distinct numbers that both satisfy. And there it is. So there's one case, an equation that involves one absolute value sign. The second one on our list was an absolute value inequality, a case where our absolute value is less than or equal to some defined number. Excuse me. So here's a case where we're going to think about that absolute value as distance, and we need our distance to be less than or equal to 18. So one way to approach this, and the easiest way, is to just say then that 0.75x plus 3, the argument, the thing inside the absolute value sign, has to be somewhere between negative 18 and positive 18. Now we can solve this 3-part inequality, or I call it a sandwich inequality, because our variable is sandwiched between the upper and lower limits. We're going to subtract 3 from both sides, all 3 sides actually, and then divide each part by 0.75. There's no sign flipping necessary there, so it's okay to just treat all 3 parts together. And it turns out x needs to be between negative 28 and 20. And so our solution region will be the interval, the closed interval, negative 28 to 20, where we can include both endpoints on that. The thing to notice here is, though, we're talking about a distance less than some amount, and so we have a single region somewhere in the middle of the number line. The third example I had to review with you was an absolute value equation where we had absolute value signs on each side. Here again, the key is to really just recognize the 2 relevant scenarios. One case is that the 2 arguments, 3x and 7x plus 12, were the same to begin with, and the absolute value signs really don't change that. Or the other case is that they were opposite signs, and I chose to just make the one on the left negative since that's the simpler one. So there's the 2 cases that we need to consider. And of course they can both be solved without too much trouble. I trust that you could do the algebra. Our left scenario yields a solution of x equals negative 3, and the right solution yields a solution of x equals negative 1 1/5. And finally, we had an absolute value inequality where our absolute value is greater than some defined distance. So here think we've got a distance greater than 6, or numbers that are out beyond a certain distance from 0. So to set that up, and again this is really the key to the problem, the argument 3x over 5 plus x over 2 can be greater than 6, or 3x over 5 plus x over 2 could be less than negative 6. So these are going to give us solutions way off on the right side, and this will give us our solutions for x way off on the left side. Now in both cases you would multiply by 10 to clear fractions and solve for x. And the left scenario yields the result that x is greater than 5 5/11, or you could say 60 over 11 there. Or another possibility is that x could be further off to the left, that is anything smaller than -5 and 5/11ths. So as we write our solution, that's going to be the combined interval. Oops, I see I made a mistake there. That should be a negative sign in front of that infinity. I missed that, but a negative sign out in front of that infinity. You got that right. Negative infinity up to -5 and 5/11ths, joined with 5 and 5/11ths up to infinity. I just got to fix that. There. Alright, that takes care of that. You can go ahead and finish up the WebAssign now. Watch for another video where I'm going to finish up some of the other topics that we ran low on time with on Monday.